All right, I'm going to do number 64 in chapter 2. And this one, the question says, Bob is driving the getaway car after a big bank robbery. He's going 50 meters per second. Well, let's start out with our graphic here. Here's the car. The car is going 50 meters per second. Initial velocity. When his headlights suddenly reveal a nail strip that the cops have placed across the road 150 meters in front of him. So 150 meters out here, there is a nail strip, where if he drives over it, all his tires go flat. If Bob can stop in time, he can throw the car in reverse and escape, but if he crosses the nail strip, all his tires will go flat and he will be caught. Bob's reaction time before he can hit the brakes is 0.6 seconds. So the time to hit the brakes is 0.60 seconds. And his car's maximum deceleration is 10 meters per second squared. Does Bob start before the nail strip, and by what distance? All right, so what we have to do is figure out how far Bob goes and compare that to the 150 meters and see if it's less. If it's more than 150 meters, then he's going to jail. If it's less than that, he can get away. So what we have to do is we say for the first 0.6 seconds, though, up here, he's going at a constant velocity. He doesn't start slowing down until this point here. So let's figure out how far he goes. Well, constant velocity is just distance is equal to velocity times time. So the distance he goes before he hits the brakes is 50 meters per second times 0.6 seconds. And so the distance he goes before he hits the brakes is 30 meters. All right? And we have to realize we have to do this separately. So it's really a two-step problem. Because in this part, it's constant velocity for the first 30 meters. And then this is when he's decelerating. Or usually we just say accelerating. I know most people think accelerating is speeding up, but for us acceleration can also be negative, as long as it's the opposite sign. But 30 meters he does that, the total is 150 meters, so we've got to figure out how far he goes while he's accelerating. So we're going to use this equation. If we use this equation, though, we would have to know the time. But we don't know how long he has. We know distance. We want to figure out the distance, but we don't have the time. We have the velocity, we have the acceleration, but we don't have the time. But we could use this equation. Remember, these are the constant acceleration equations. Because in this one, we know the initial velocity. We know the final velocity is going to be zero. The initial velocity we have, that's 50 meters per second. We know the final velocity is going to be zero, because that's when he's going to stop. We know the acceleration. What we want to solve for is the distance. So we're going to use this equation, and we're going to solve it for the distance. The initial position we're going to call 0, or you could call it 30, but I'm just going to call it 0, and then we're going to add them together at the end. You can do it either way. And so we're going to solve this for x. So this becomes v squared minus v naught squared, is equal to 2ax. And then x is just going to be v squared minus v naught squared over 2a. So in this case, the initial velocity, or the final velocity is 0. The initial velocity is 50 squared, right, over 2 times the acceleration. But remember, the acceleration is positive that way. The acceleration is this way. It's decelerating, so this is negative. So you got to put in negative 10. And you get that the distance that he goes is 125 meters. All right, so he goes 125 meters after he's accelerating. He went 30 meters before, so his total distance is equal to 30 plus 125, or 155 meters. But the nail strip is at 150 meters, so he hits the nail strip, he ends up going to jail. And so the moral of the story is crime doesn't pay.